Listen-only mode.
Good morning, good afternoon. Welcome to the webinar from Smartlogic on Semantics in Action with Semaphore 4. We will be conducting this webinar in broadcast mode. All attendees are muted. Please put your questions in the question box in the GoToWebinar console, and we will answer those questions when we get to the end of the scheduled portion of this broadcast. My name is Ann Lapkin, and I manage strategy and marketing for Smartlogic. And with me today is James Morris, a senior information scientist with Smartlogic. Today we're going to talk about the hyperconnected enterprise and what impact that's had on information management. We're going to talk about the role of metadata and semantic technologies in the new environment. We're going to talk about semantic standards and data principles and how Semaphore 4 has actually embraced those. And then we're going to talk about a real-world business problem, the identification of medicinal product standards, which is a new regulation coming out of Europe for the pharmaceutical industry, which is presenting pretty significant problems in information management. Then we're going to do a live demo, and Jim is going to show us Semaphore 4 in action, and then we're going to talk about classification and analysis and what the impact is of those things on the unstructured information assets that you have in your enterprise. And then we'll have questions, so please, as questions occur to you, put them in the question box. We'll get to as many of them as we can before the end of the broadcast. The slides will be available post-broadcast in an email that will be sent to you after the webinar, with some additional handouts on the business benefits of Semaphore 4. So let's talk a little bit about the hyperconnected enterprise. This is a concept that's been around for quite some time. I think Gartner first drew this picture in 2008. And the fundamental premise was that organizations are no longer centralized, very isolated organisms, but rather they have moved to being a collection of business units that need to exchange information and interact with one another. They moved on from that to having to introduce external parties into the equation as they began to outsource some of their non-core competencies. And they have increasingly had to include other entities on the periphery, customers, business partners, and so on and so forth. And what we have now at this point is essentially a network of interconnected components. You have the corporation, which interacts not only with other parts of the corporation, but also with customers, with business partners, with regulators, and so on and so forth. So businesses are no longer isolated. They can no longer carefully control the exchange of information. They are increasingly dependent on external information that they did not create themselves in order to conduct business. And they need to increasingly cooperate with partners, with very often with competitors. In many, many industries, you find now that enterprises are entering into joint ventures that require them to exchange information. So on one hand, they might be competitors, and on the other hand, they're also business partners. Exchange with regulators is increasingly important, and of course of paramount importance is exchange with customers. So what is the impact of all of this on information management? So first of all, organizations need to easily share information. And what that means is that the information needs to be structured in a way that makes it easily exchangeable. And organizations need to quickly adapt to change. And what that means is that information needs to be used in different contexts, so it needs to be reusable in different ways. And that creates some issues because while we've pretty much solved that problem for structured information, for the stuff that's in your relational databases, in large part that has not been solved for the unstructured information assets, which actually comprise about 80% of the information in the enterprise and actually where most of the human intelligence of the enterprise is stored. So if we look at the recent study from IDC, IDC periodically does an estimate of the amount of information that's in what they call the digital universe. And they have predicted for a number of years that that information will grow to a massive size. They are projecting right now that the total of information in the digital universe will be about 40 zettabytes by 2020, and the information is doubling, more than doubling every year. So there's exponential growth there. The vast majority of that information is unstructured. And what IDC has also said is between 30 and 35% of that information is actually useful. The rest of it is just noise. But you don't actually know if it's useful unless it's been tagged and analyzed. In other words, some structure has been added to that information so that computers can actually determine what information is relevant, in what context it's relevant, and so on and so forth. Beyond that, IDC has also said that of that 35% of information which will be useful if it's tagged and analyzed, only about 5% of it actually has been. So what does tagging and analyzing mean? Tagging and analyzing means that the content of the information has been examined to determine what facts it contains, what relationships it contains, essentially what it's about. And that information that describes what the information asset is about has been tagged to the asset in the form of metadata. And one of the places that Smartlogic actually excels is in the analysis of that 80% of the information in your enterprise which is unstructured, and the ability to extract facts, relationships, entities from that information and tag the information assets with the relevant metadata. And the reason that this is important is because there's so much of this stuff out there that we can no longer expect humans to be able to cope with the volume. So in order for us to determine which 35% of that information is actually valuable and then be able to actually put it to use, we need to be able to have computers do that work. And that's where we get to the concept of semantic technologies. Gartner has defined semantic technologies as technologies that make the meaning in information explicit for the purposes of human and/or machine interpretation and communication. Now, there's been lots of talk for many, many years about the semantic web and the promise of the semantic web and so on and so forth. But what most people don't realize is that none of the information in your business is useful without metadata. And semantic technologies are great, but you have to put them to work. You have to put your ontologies to work actually classifying the information assets that you have and tagging the information assets that you have in order to be able to leverage both internal and external data sources. And with that, I'm going to turn it over to Jim to talk about hyperconnected metadata, which is essentially a new paradigm for exchanging data and information.
Thank you, Anne. Yes, as we've been discussing, metadata is what we use to improve the usability of our information assets, to make the information in those assets explicit, so information can be analyzed and used by computers, not just human beings. But it's not enough. We need to connect our information in metadata in more lightweight ways, as opposed to warehousing and large-scale integration projects. So we're really talking about more about coordination versus control, interoperability versus integration. And so when we think about what paradigms are there for doing that, and in fact, we already have one. Maybe you've heard of it, called the World Wide Web. It's been around a while, and it does exactly what we're talking about. But the thing is, it only does it with pages or documents. It's essentially what the web is. And there's a lot of complexity behind the scenes and a lot of applications built on it. But essentially, it's a web of pages. And they're hyperlinked together with a few basic standards. And it's wildly successful. So what people don't always realize is that that same paradigm, that same technology and standards, they're also used to link data together. And the amount of data that's available in this format is growing all the time. On the right, you see an image of a bunch of little circles connected together by lines. That's called the Linked Open Data Cloud, and it evolves every year. And it's showing all the data sources that are out there available on the web using the same web standards that are available and linked to each other. And I want to mention it's important that this bubble only includes those data sets that are actively linked to others. But the format that data can be stored in is even larger than this graph represents, because there are data sets out there that can be reused that aren't necessarily automatically connected with other sources. So we're talking about web of pages, web of data. What's really the difference between those? I mean, thinking about the web of documents, anybody can create a new page. Anybody with a computer and a couple of dollars can create a page on a particular topic and give it a unique address. And from there, write some information and link to other pages. It's really basic. And think about that, a unique address in all the universe. It's amazing that how well that standard works for creating URLs, addresses for things. But the limitation of that is to understand the information on that page. So a restaurant page has hours available, menus, things like that. You need to read it, and it seems kind of obvious, but it's an important distinction. The only way to know that that information on that page means something is for you to actually read it and interpret it. But when we talk about linking data together, we're looking at that information that's behind that on those websites and encoding it using those same web standards so the computers can interpret it. They can look at that data and say, that number, that's actually an opening, the hours that a restaurant is open, that type of thing. And that's how the data becomes interoperable, the same way the pages are interoperable. So a little more about these standards that enable both linking of pages and linking of data. They're semantic in nature, and that's why this is sometimes referred to as building a semantic web. As you link data together, you actually talk about what the data actually means so that a computer can understand that. And so when you start linking all that together, you become a web of meaning, a semantic web. And it's because the data is encoded using standard data formats and then shared over common exchange protocols, just like the web of documents. And the way it does this is by encoding data in what are commonly called triples. That term seems to be taking off a lot more when we think of data that follows these rules. But triples is a very simple concept. It just means you're talking about a subject, a predicate, and an object. So it's an ability to make a statement about anything. It's like an atomic form of intelligence. It's the most basic thing you can say. So for example, Smartlogic is a company. That's a triple. Smartlogic is a company, subject, predicate, object. A company is an organization. That's another triple. If we think about like a medical example, we could say a particular disease, congestive heart failure, is a disease or is a cardiovascular disease. That's a triple. Cardiovascular or congestive heart failure is treated with ACE inhibitors. It's just subject, predicate, object. It's elegantly simple. And then within particular domains, people have developed ontologies. And in this sense, the ontologies establish a framework for data to be shared within that domain. So it just adds another level of meaning onto the content, onto the data that you're looking at. For example, you might have an ontology that deals with the nature of organizations or companies. And so if we use the triple Smartlogic as a company, then our ontology might say, if Smartlogic is a company, then it must have an address, or you can expect that there's an address. So that's what's sometimes referred to as inferencing. So it allows a computer to look at a piece of data like Smartlogic as a company, and then the computer will know that, there must be an address here as well. And you can kind of expand that out from there, thinking of the discipline that you might have expertise in, how all that information about that discipline is connected according to particular rules. The last little bit to mention is this thing called RDF. Sometimes that throws people off, but RDF, it stands for Resource Description Framework, and all it is the triple. It's the fundamental building block of linked data and the semantic web. Now, Smartlogic, Semaphore, we've been compliant with these standards for some time now, being able to both consume and publish our ontologies and vocabularies in triples or in RDF. And we also produce our classification metadata. So when we analyze documents and extract the necessary metadata from them, we can produce that as triples as well. And that's important. We'll look at that a little more detail later. But with Semaphore 4, our new version, we take that a step even further. And it's because we understand that our clients don't just need to manage vocabularies in an enterprise taxonomy type context or within a particular area. They also need, and they don't just need to classify their content and improve findability and improve search, improve content management. They also need these ontologies and classification metadata to be structured in a way that can be easily exchanged, easily reused, and then analyzed in this widening information ecosystem that we were referring to earlier as the hyper-connected enterprise, because it's a hyper-connected world. That's the nature of the web. So next I want to talk just about a practical example where this can come into play. As Anne mentioned earlier, IDMP stands for Identification of Medicinal Products, and it's a new regulation. It's still being finalized, but is going into effect in July 2016, starting in Europe. The purpose of the regulations is to collect the individual data elements about medicinal products, covering manufacturing details, where is it made, who makes it, to clinical properties, authorizations, who approves this product, packaging information, etc. Anything that's necessary to uniquely and with certainty identify medicinal products. And in order to be compliant, pharmaceutical companies have to collect information housed all over the enterprise in various formats. You have to remember that a pharmaceutical product can take 10 to 15 years to develop it, so that the wealth of information, covering pretty long time spans, is amazing. So, but the trouble is, a lot of that data is still in documents. I mean, documents get approved that kind of summarize a particular pharmaceutical product, your product inserts, for example. These are all documents that have been approved, and it's really the official record for what these drugs are about. So in order to extract information from them, you're really talking up to 70% by some estimates of the information that holds the data you need to with which you need to comply with IDMP regulations is still in documents in a format that essentially doesn't have the data necessary for computers to work with. So it means you need to set up a whole operations to interpret this information using your human staff, your people, because that's the only way you can interpret it. Now, Semaphore, of course, as we've mentioned, and if you attend these webinars, you know we're the content intelligence platform, and this is the problem. These are the problems that we solve. We extract facts and concepts from unstructured text and documents, and while the the data that needed to comply with the IDMP regulations is locked in these documents, Semaphore is a tool that can extract the metadata and to be so that it can be applied to the IDMP data elements. Now think about this: the IDMP regulation. We have a little snapshot of a high-level view of it, but it's basically there's several elements, cascading hierarchy of elements that all connect to each other, and many of the data that is required to feed back to the regulation uses controlled vocabularies, public controlled vocabularies. And so when you start analyzing your content and trying to find the data that you need, you often need to reference these other ontologies. So you can get a picture of kind of the network of ontologies and vocabularies, as well as the structure of the standard that needs to all come together to be compliant. So it fits very well with the idea of linked data and being able to pull this data together quickly. Because July 2016, companies don't have time to build yet another data warehouse that brings all this information in. We need to be able to connect our information more efficiently. Now, in the content intelligence process that Semaphore uses, what we do is we start with modeling the concepts and relationships that we're interested in. So we build these vocabularies, these taxonomies, these ontologies that model our knowledge. And even that part is especially can benefit especially from this the linked data model, because as we saw in that big linked data cloud, there's a lot of information out there that we can leverage to build these knowledge models that already exist. We don't need to reinvent the wheel. And that's the piece of the puzzle that I want to demonstrate with Semaphore version 4. Because as Anne said earlier, these semantic technologies are great, but you really need to be able to put them to work. And that's what Semaphore version 4 does. So let me just switch my screen here for a second. And here we're looking at the dashboard for Semaphore version 4. We're looking explicitly at the model manager piece of Semaphore version 4. And here we have all the different ontology models that I have available to me. And we're going to look specifically at this pharma demo model that I created. And it might it's specific to pharmaceuticals, what an enterprise taxonomy might look like in a pharmaceutical company. But you could imagine your own organization in this structure as well. We have fundamental facets of products or brands, Drugs are things, are the, our product, what we call them. We might have an organization branch, different aspects of our products that we manage. And the facet I want to zero in on is this concept of therapy area or indication. As you know, when you develop drugs, you develop them for a specific purpose, to be a specific therapy, to treat a disease or some other condition. And what companies usually do is they organize their their business around these concepts of therapy areas. So while it might not be strictly scientifically correct, we might bundle things like cardiovascular and metabolism together. And then we might break things down into subdivisions, diseases and procedures and metabolic diseases. So there we might have our diabetes franchise. And I want to point that out because it's an industry-specific or a company-specific construct, this idea of therapy areas. Now, we have a couple diseases here, and remember what we're talking about is organizing an ontology so we can do content classification more effectively. So how does the classification work? I mean, we look at a document, we look at any particular information asset, and determine what that content is about, or that section of text is about. I'm looking at a particular document for information that's needed to comply with the IDMP regulations. Like, what is the official indication for this particular drug? So when we're doing that, we might be looking for disease terms. And to do that, these disease terms could be called by a variety of names. I mean, if we look at this one example of acute coronary syndrome, we have one acronym here. We've got some metadata like a definition. It's related to a particular drug for which it's the indication, etc. That's pretty basic metadata here for this concept. But if we really wanted to do classification in the best way, we want as much information as we can get about these concepts. We want a lot of synonyms. We want relationships to other products, and that's what Semaphore uses to analyze content and return the best answer. So, but imagine the effort. I mean, if we have tons of diseases, indications to add here, how are we going to add all this information? It's the same challenge as we've seen before. You can't just start recreating information that already exists. And that's the good news, because as we saw in that linked data cloud, this is a huge discipline, creating ontologies for use in the biomedical community. And I want to point you to one of those in particular, and we'll talk about how can I reuse this information more effectively. So there are plenty of disease vocabularies out there. There's one in particular that I like to use, and that's the disease ontology. The disease ontology, it's an open source ontology. It's intended for the integration of biomedical data. It's a community-driven, community-accepted ontology. It's explicitly targeted at clinical research and medicine. They've got a great page, and again, it's an important point. It's a page. This isn't, it's intended to be browsed by a person, and we can browse this hierarchy and find information about different diseases. And here I've selected congestive heart failure, and we can see it's got good. This might be a term we need to add to our ontology. And we say, oh, this has got a lot of good information in it. It's got a few different synonyms. It has cross-references to other systems. It's got a good definition. So how can I use this? Well, if you put the whole idea of linked data aside, how would you use this? You could cut and paste it, or you could program a screen scraper or something to pull this information out and have to determine where, what these different tags mean, and that's, without any other paradigm, that's basically the solution. But the great news is is this is available as linked data. So they've encoded all this information. In fact, it's built on a platform of information that is intended to be used as linked data. So we can actually get this information and pull it directly into Semaphore. And that's the big difference with Semaphore version 4. Since we're already natively based on triples, bringing in another ontology that's triple-based is extremely easy, and that's what we're going to see. So let's go back to Semaphore. And if we go back to our main screen, there's now a feature of Semaphore to be able to link other models in. So here we have a list of different models that can be brought in, and I'm going to take my human disease ontology and add it to my enterprise pharma demo. Now if I go back into my model, you can see there's a new branch, and this is the concept scheme coming in from the disease ontology, and we have a little icon there that shows that it's a linked vocabulary. So it's just linked. It's not really imported. It's just referenced, and that's a really important distinction. It's the nature of linked data. It's just like when you link to another document from your web page. You're not bringing that document into your web page. You're linking to it, and it's precisely what's happening here. And we can see our cardiovascular diseases here as well. So it's all there available to us. But if we go down to our enterprise taxonomy part, and we say we need to add a new indication here, and we need to put it under cardiovascular disease. We have a new product, for example, that needs to reference a particular indication. So now that we've linked our disease ontology in here, we can, when we start looking for other terms to add underneath cardiovascular diseases, we can see all the terms coming up here are from not just my taxonomy, but from the related taxonomy as well, from the linked taxonomy. So here's congestive heart failure. We'll select that and add it. And now it's part of our ontology. You can see it right here in our same hierarchy. And when we select it, we can see it's got all that rich information coming from this other source. And now we can use this in our classification schemes, just like if it was a term that we managed ourselves. We can even add additional relationships to it. For example, if we wanted to indicate what product might have this as an indication. And this is just adding data, it's just connecting more links to the disease ontology. It's not modifying the disease ontology at all. And that's a really important concept, because in the past, that's what we would have to do. We'd have to import all these and integrate all these ontologies together to make use of all this additional information. And Semaphore's done a lot of that work over the years, and we do it very well. But when you can just refer to it, it makes things much more manageable. You can even break apart your ontologies into different parts and have them managed by different parts of the organization. And when they need to reuse terms from elsewhere in the company, they can just link to them. It makes governance more effective, and it makes the reuse of information much more effective and efficient. Now, this is fairly basic. We're just bringing in one ontology, and we're linking to it. We're adding some additional properties to it without corrupting it. But it really shows a whole new paradigm, and fully embracing that new paradigm. In one sense it's new. In the other sense, it's the web. We're just embracing the full power of the web to manage not just pages, but manage data and the critical metadata as well. That's what Semaphore is about. So we'll go back to the presentation now. And we've talked a lot about classification, what Semaphore is so good at. I want to mention that other than the Ontology Manager piece, which is what we were just looking at, our classification server as well has taken a big step forward with this release. And it's great improvements in terms of the complexity of the information that we can extract, as triples, and the network of vocabularies and models that we're able to pull together. Ability to create, to not just extract particular facts, but extract facts and relationships to other facts. So, for example, we might have a document that lists several prescriptions. Now, what is a prescription? A prescription is the specific elements of a person or a patient, a dosage, and a drug. But altogether, they form a prescription. So now our classification engine can produce that type of information. Say this document has 3 prescriptions, and each of those prescriptions contains these 3 elements. So it really opens up a lot of possibilities for classifying content effectively. So what do we do with all this information? Semaphore has been used extensively for improving search, improving content management, but it's also being used for analytics. And the fact that we are fully embracing RDF and the concept of triples for this information, we can do really exciting things with that content, with that data that we're producing. So if we look at this next slide, this is a lot of information on this slide, but we'll get into the specific, we'll talk in general about what we're doing here. What we're looking at is a set of classification data produced from documents and the ontology terms that were found in those documents. So the gray boxes represent documents, and the little purple boxes represent the concepts that were found in those documents. So starting in the center, like the lower left, I guess, what we see here, we've discovered a set of documents that are kind of cluster around 2 concepts. In this case, corticosteroids and kidney transplant. And that's interesting because our ontology doesn't explicitly identify a relationship between corticosteroids and kidney transplants. That's interesting. That might be additional knowledge that we need to add to our ontology. By seeing what documents cluster around these 2 concepts, we're discovering new relationships and improvements to our understanding of this particular domain. And we can actually add that to our ontology. So we're continuing to improve our understanding of a domain by analyzing the documents and viewing them in this way. We can also leverage the relationships that already exist in the ontology. For example, we could follow the path from corticosteroids to chronic renal failure to anemia, and we can look at concepts that might cluster around anemia. And we might discover there might be other documents related to those concepts. And so we might discover a possible potential new therapy, a new product extension, if we see documents that cluster around these related concepts that we wouldn't have seen any other way. Now imagine trying to go through this thought process with a traditional search engine. It's entirely linear, going from one search, trying to look at the results, maybe making some lateral moves to other concepts, and it's step by step. Here we're looking at the whole process in one view, and we're really capturing just another way of viewing this information that's really not possible before. And this type of analytics really, takes things to another level, being able to, predict what new information. You can. This could be used to find out, gaps in your content. If you're analyzing content for and documents for metadata to feed into this IDMP regulation, looking at it this way, you could see, I have information about these concepts, but not these concepts, and see, how these the documents cluster together to produce new information. So this is just an example. I mean, you can kind of imagine in your own discipline how you could leverage this information in this way. So that's the view of Ontology Manager in Semaphore version 4. We talked a bit about classification server, and it's really about producing all this information in a format that can be used to advance your understanding of the information in entirely new ways that really weren't possible before, and we're very excited about that. So with that, I'm going to turn it back over to Anne to kind of summarize where we've been and take some questions.
So where have we been? Well, we've been in a number of different places, but what this basically boils down to is the ability to extract the meaning and the human intelligence from your information assets, to be able to allow computers to do that in order to cope with the volume, to be able to link and leverage external sources of information and expertise in order to make your use of unstructured information better and easier. And interoperability both within the organization and outside the organization, and the ability to connect with customers, regulators, partners in a way where the exchange of information benefits all the parties. And with that, I'm going to look at the questions. We have quite a few questions here, but one that's come up several times is, it looks like there are plenty of external ontologies for pharma, but what about other industries? Where do I find these? Where do I find these external ontologies, and do they exist for domains like finance? So, Jim, if you'd take that one.
Sure, absolutely. Publications, finance, agri-science. You can look at the Wikipedia itself is available as linked data. In fact, if you look at that cloud, the hub of the whole thing is the Wikipedia, which obviously links to many different types of information. You'll see, if you search on Google, sometimes you'll see a panel come up on the right-hand side with information about the topic you're looking for. Like, for instance, if you look for heart disease, for example, you'll pull up a card on the right-hand side that tells you about heart disease. So it's doing more than just search results. Where's that data coming from? It's coming from linked data, essentially. It's being provided by different sources and aggregated into that card. That's another medical example, but you could search for any topic where you see that information come up on the right-hand side. That's linked data. So it's very much in production in a wide set of disciplines. So I would take a closer look at that cloud. If you see the slides there where you just look for linked open data cloud, you'll find it and explore that, and you'll see all the types of information that are covered.
Another question that was asked was, what happens when the linked ontology changes?
That's my favorite question, because what would happen before when you had to integrate content from other ontologies, into your structure of your own, proprietary structure of your specific ontology. Now that's hard when those ontologies get updated. The great advantage of being able to keep them separate and linked is that your linked data source has not been corrupted, so it's exactly the same as it was. And when you get a new version, there's the tools behind the scenes that we use to manage linked data, such as the Sparkle query language, where you could do a much more controlled process of migrating to a new version. So you could use that to say, have any terms in this particular ontology been used in my other ontologies? And has it changed in this new version? If it hasn't, you just load the new version on. The fact that each term has a unique identifier based on the same web URL standards, URI standards, it means that you upload a new version, and if that term hasn't changed, nothing happens. If new properties have been added, they get added, and all that gets taken. And if you've linked to any of those concepts, you see all that new information in your in your own vocabulary where you've pulled in that information. So I'm not saying it's the easiest thing to do in the world, but the whole design of it makes it possible to do it the right way and the most effective way.
Okay. Lots of questions about your power of analytics slide. Some people have asked how that was created, and how you can display that information. And someone else asked, are the relationships the ones that were discovered by classification server itself? So can you talk a little bit about how you created that?
Sure. Yeah. Well, it starts with it has both data from the ontology, and it has the classification data that was generated using that ontology. And it's an important point because then the terms that you saw there, the concepts that both were in the classification data and in the ontology, immediately linked together because they're the same thing. They have the same identifier. It's the essence of linked data. So immediately you're able to pull that information together and analyze it. That's why we're able to see both documents that have particular concepts, as well as documents that documents that share a particular concept, and documents that share a set of concepts that are only related to each other because concepts in the ontology are related together. How did I generate that picture? I used a third-party tool. It's called Gruff, and it's built on the Allegograph platform. It can use any triple database, but in this case, I used that set of tools to generate it. But there are plenty of other visualization tools out there that can be used. There was a second part of that question. Oh, the relationships we're seeing on that slide. There's two. It's kind of it's a simplified view, so it's showing two different relationships. Both the relationships between concepts, so the related relationship between concepts is in there, as well as the relationship between concepts and the documents that contain those concepts.
Okay, there's a quick question on whether I can use Semaphore in the finance domain, and the answer is Semaphore is in use in a wide variety of different vertical industries, including financial services, including pharmaceuticals and healthcare, including manufacturing, both discrete and process-oriented. Really, Semaphore is useful anywhere that you have a large volume of unstructured information where you need to be able to extract and leverage the intelligence that's in those information assets. There are, as Jim said, many external ontologies that are available for financial services. You can link them to your existing ontologies. You can start with some of those as a base and build them out with terms that are specific to your organization or concepts that are specific to your organization. But Semaphore is widely used in a wide variety of industries because it's a piece of platform software, and it doesn't the contents of the model, which are modeling the problem domain, are what drive the usage in any particular industry or environment. Couple of other good ones here. This is a short one, so I'm going to take this really quickly. It says, is Semaphore 4 available for download? Looks like the one on the customer portal is not enterprise ready. We have not yet made available a link to Semaphore 4. It will not be downloaded. Semaphore 4 is entirely based on web technologies, and the trial version will be a link to an ontology management site that we are hosting. We should be releasing that in about a week. In the meantime, Semaphore 4 became generally available at the end of last month and is already in use not only with the customers who participated in the beta program, but also with customers who are beginning to migrate. Here is another one which is kind of interesting, and I'm going to ask you to answer this one, Jim, and it's, can you use your ontology manager to upload and author an OWL ontology as an alternative to Protégé? And if not, what is the relationship between an ontology you can author in your ontology manager and an OWL ontology?
Wow, that's great.
I might point out that most of the ontologies in the linked open data space are OWL ontologies. Am I correct?
Certainly in the biomedical domain, that's probably true. But again, yeah, and one of my favorite topics. So I think another person in the questions observed this as well, that the paradigm that Semaphore 4 uses is a thesaurus paradigm, but we're looking at narrower terms, broader terms, related terms, and that's a particular framework for that type of content. We call it SKOS, S-K-O-S. But the disease ontology itself is an OWL ontology, and so we were able to still make use of that in Semaphore, and that's, I think it's a really important point that probably could be a whole nother discussion. That if you look at the OWL ontologies, they're all very OWL as a standard is kind of like, this is my opinion, but it's kind of like Excel is a standard. It's a way to model information, and you can model anything you want in any way you want, essentially. And so each OWL ontology, even within the same domain, might use different property names, might use different relationships, all generally looking, following the OWL class and property structure. But in order to make use of that, exactly in our use case, we need to classify content, and that's in Semaphore's engine, we want to use multiple ontologies in our classification schemes. So when we use our OWL ontologies, we do represent them in a language that makes them interoperable with other vocabularies that we need to use for classification, for search engine enhancement, for content management system, metadata enhancement. So and again, it's really built into the standard itself to be able to use these ontologies in different ways. So absolutely, I mean, using OWL ontologies in Semaphore is a major capability.
Okay, there's another question here about how the ontologies are composed. Are they composed manually except when you link to external ones? And in that latter case, are the terms automatically recognized and classified? And are ontologies always hierarchical, like in the Explorer on the left? There was also another question about the difference between a taxonomy and an ontology, so maybe you could address both of those here, Jim.
Sure. I'll start with the difference between a taxonomy and an ontology. Again, we could do a whole seminar on that topic. You know, a taxonomy is, I would say, is a very simple ontology. It gets very confusing in the semantic web linked data space because ontologies refer to, like, OWL itself as an ontology, but then we also refer to you know, a medical thesaurus as being ontology. So it can sometimes throw people off. Essentially, there are two interoperable forms of you know, managed concepts in a sense, and you know, taxonomies have been around forever, and now that they are can be modeled in this linked data format, and these other types of ontologies are modeled the same way, that opens up all these possibilities to be able to reuse information and make it interoperable. There was one of the first questions there was about where did the data that we looked at come from, and how was it created? Yeah, it's a great point, because you could use Semaphore just like you can use it now. You can use Semaphore version 4 to just create an ontology from scratch, and that may be what you need to do. There may not be sources to leverage yet, or you may not need to do that. So it's designed to be a very easy tool to use to create these vocabularies, taxonomies, according to whatever your need is. It doesn't necessarily have to come from somewhere else. And yeah, were there other points there in the middle that I skipped over?
No, that's fine. We'll be answering these questions to the asker by email. Okay. What we're doing here, because we're actually running out of time. But there was one last question that I wanted to address, and that was a question from someone who said, on your power of analytics slide, there seemed to be a very, very small number of documents. What do you do in cases where there are very, very large volumes of documents? And I would start by saying that in almost every case, we are dealing with extremely large volumes of documents, because if they're small volumes of documents, then there's really no point in bringing in a tool to handle them. But at the same time, I think it's worth talking about a little bit, and also the fact that I think you simplified that diagram a little bit for this webinar.
Yeah, absolutely.
Talking about the volume of documents that Semaphore can handle.
Yes, that's exactly right. I mean, it's purely illustrative of, you know, some of the connections that you can make. I mean, those visualization tools are to, you know, depending on the one that you choose, are, you know, intended for that. You can zoom out and see clusters in a much more abstract level, and only, you know, look at the areas that are of particular interest to you. You know, you see 10,000 documents clustered over here around a set of concepts. Then you zero in to see what's going on, and do further analysis on those clusters. You know, Semaphore provides the data in a format that can be used to do that type of analysis, but the choices of tools on what you to produce those visualizations is really up to you.
Okay, so there are a number of questions that we didn't get to here, and we will be answering those questions directly by email. I thank you all for attending the webinar today. I hope you enjoyed it as much as we did, and we look forward to seeing you at our next one. Thank you very much.
Thank you.